Hello friends and welcome at my channel. Today one more function f of x equals to 4x divided over 4 plus x squared. Okay, as you can see the denominator is never equal to 0, so we are never in troubles. X could be every possible real number. That's the domain stuff. Number 2, what do we have? Symmetry. Well, f of minus x is equal to 4 times minus x divided over 4 plus minus x squared. So this is minus 4x divided over 4 plus x squared. We can take minus in front. Minus 4x divided over 4 plus x squared. And this is obviously the same as minus f of x. So we're symmetric considering the origin. Number 3, we have no problems, so just plus minus infinity, that's it. And keep in mind we have symmetry as well. So what's happening here, the denominator is winning obviously, so we have 0. And well, let me write it also here, minus infinity. We got 0 as well. Number 4, 0 points. 4x divided by 4 plus x squared equals to 0 if and only if the x value is 0. So 0 point is at 0, 0. Extreme values. First derivative. We got 4 times 4 plus x squared minus 4x times 2x divided over 4 plus x squared squared. Can I simplify something? Let's see. It's going to be 16 plus 4x squared minus 8x squared divided over 4 plus x squared squared. So what do we have here? We are having 16 still minus 4x squared divided over 4 plus x squared squared. All right. Where is this value equal to 0? Well, obviously, if x is equal to plus minus 4, right? Check it. Seems to be right. Second derivative. Let's quickly do this one. What do we have? We have minus 8x times 4 plus x squared squared minus 16 minus 4x squared times 2 times 4 plus x squared times 2x divided over 4 plus x squared to the power of 4. All right. Can we simplify something? I think we can. Take 4 plus x squared outside of the parentheses in the numerator. So we are going to get minus 8x times 1 more 4 plus x squared, and then we are having minus 4x in front, and then 16 minus 4x squared. Close the parentheses here again, divided over 4 plus x squared. I think it was to the power of 4 if I'm right. It is, so we just write cubed and 1 more 4 plus x squared, that's it. Let's cancel it. All right, now let's multiply it out in the numerator. So we're going to get minus 32x minus 8x cubed minus 64x plus 16x cubed divided over 4 plus x cubed cubed. So what are we getting? We're getting 8x cubed, as you can see, and minus 96x divided over 4 plus x. Was it squared? I think it was squared, right? Things are mysteriously changing during the solution. Cubed. All right. So this is the second derivative. Let us put into the second derivative in order to figure out max or mean, because of the symmetry, I'll only do it once. Let's put plus 4 inside. So we're going to get 8 times 4 cubed minus 96 times 4 divided over 4 plus 4 squared and the whole stuff cubed. Don't forget, we're only interested in the sign. It shouldn't be 0. Everything else would be fine. All right, we got 8 times 64 minus 96 times 4. Who's winning? I don't know yet. We will see. 16 plus 4, 20. 20 cubed. 2 cubed is 8. And we got 3 more zeros. All right, so the denominator is fine. Is 8,000, so we're doing well. I can also kick something out, right? I can kick 8 out here. It's going to be 64 left over minus 4 and 2 more. It's going to be 48. You see, I'm doing fine. So I can cancel this. 64, it's 16. So it's 16 divided by 1,000. It's just positive. Very, very small number, but it is positive. So we have a min at 4. And our function was 4x divided by 4 plus x squared. So if I put 4 there, I'm going to get 16 in the numerator and 20 in the denominator, which can be simplified by 4. It's 4/5 or 0.8. There you go. So obviously, because of the symmetry, we got max at minus 4 and minus 0.8. There you go. Am I right? I think I am. All right. Second derivative, which is here. I would like to put it equal to 0 as well. 8x cubed minus 96x divided over 4 plus x squared cubed. As you remember, the denominator does not matter. So we're having x out. Can I take 8 out as well? I think I can, right? I can take 8x out, just x squared remaining here. Well, we would have 12, I think, right? This is 12. That's 0. So x1 is 0. And x2 is minus square root of 12. And x3 is plus square root of 12. All right. Well, I do have, could also take the values just slightly before and behind the square root of 12 or 0, but I will practice one more derivative. So let's do it. Let's compute the third derivative here. Gonna put some effort. So it's 24 x squared minus 96 times 4 plus x squared cubed. There you go. Put myself down. Minus 8x cubed minus 96x squared, the whole stuff. 96x only, times 3, 4 plus x squared times 2x divided over 4 plus x squared to the power of 6. Next step, what are we getting? I can take again, you see it's a lot of computations, but well, I said I'm gonna do it, so I'm gonna do it. That's it. I miscubed here. Got it squared there. Now it's fine. Now I can take 4 plus x squared outside of the parentheses. I'm going to have 24x squared minus 96 times 4 plus x squared once remaining. If I'm right, I am. Minus 8x cubed minus 96x times 6x, parenthesis closed here, yes, divided over 4 plus x squared. I'll take it squared and then 4 plus x squared to the power of 4. Canceling, canceling. Life is getting easier. Let's keep it going here. Now let's multiply it out correctly. 24 times 4, 96x squared minus 96 times 4, we got 384 with minus. Next, 24x to the power of 4 minus 96x squared. Now, minus 48x to the power of 4 and plus, I need to multiply 96 times 6. Seems to be right. Yeah. So 100 times 6 would be 600. 96 times 6, I have to subtract 24, which is 576. So 576 x squared divided over 4 plus x squared to the power of 4. Was it a good idea to produce the third derivative? Well, you see, you may be still learning that even though I was admiring figuring out this third derivative, in real life situation, not on YouTube video, maybe it would be better to just check the sign. But that's the way it is. I hope I haven't done any wrong computations. If you figure out something, let me know. Let's start with the highest power, which is 20 x to the power of 4. So we got minus 24 x to the power of 4. Then we got something squared, if I'm right, minus 96 plus 96, which is nice. So we got plus 576 x squared, and then just minus 384 divided over 4 plus x squared to the power of 4. So if I am putting 0 inside the third derivative, obviously I'm not going to get 0. So that means this is point of inflection 1 at 0, and let's come back to our function, which I was writing here. 0 is 0, 0, one of the 0 points. Great. What about square root of 12? The third derivative of square root of 12, let us estimate. I don't need to compute exactly. Well, you see, squares are fine because we would have minus 24. Square root to the power of 4 is just 12 squared. All right. 576 times 12 minus, I think it was 384. Am I right? I am right. Divided over 4 plus x squared, I think, to the power of 4. Yeah. So basically 16 to the power of 4, which makes no difference. All right. So minus 24 times 144 plus 576 times 12 minus 384 divided by some huge positive number. I need to estimate whether this guy could be somehow 0. I don't want to compute exactly. That's the point. Okay, so let's see. 576 is 24 squared, right? So I have minus 24 times 12 times 12 plus 24 times 24 times 12. That's great, because I can take 24 times 12 out. Minus 12 remains here, and plus 24 remains there, which is great. I have 12, 12, 24. So 144 times 24. This is way more than 384. So this number is for sure positive. No problems. This is point of inflection, inflection 2. The square root of 12, and I can put it inside the function. So what is f of square root of 12? This is 4 times square root of 12 divided over 4 plus square root of 12 squared, which is 16, and 4, I can divide it, it's going to be 4, so square root of 12 divided by 4. And what about inflection point 3? It's minus square root of 12, and of course, because of the symmetry, it's minus square root of 12 divided by 4. Whew! Holy moly. That's the way it goes, right? And now we're going to plot the graph. I think it's going to be a long video. So 0, 0, we got it. Extreme values, we had it at 4, very close to 0, I think. Yeah, 4 and minus 4. 4, 0.8. 1, 2, 3, 4, minus 4, minus 0.8. All right, we're going to go to plus and minus infinity. We're going to go to 0 in both cases. This is the first point of inflection. The second point of inflection is square root of 12, which is 3.3 approximately, right? Something like this. 3.4 rather. 3.5 is 12.25, so 3.46, let's say. 1, 2, 3, somewhere there. And somewhere here. Do we see how it works? We do, I think, right? Mean here, going up, 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 up. Point of inflection changing. Max going down. Is that nice? I don't like it. I'll try to draw it with a finger. So going like this, then there. Slightly better. Uh, okay. I think, those points must be a bit more diverse. Is that better? I think so. All right. So the last one is like that. Okay. So that's the graph. Thanks for watching. Sorry for the mess. See you in the next video. Bye bye.